The last video had some great examples for the product rule, but we're going to try doing the quotient rule for these last two here. And remember, we're trying to find the double derivative, find f double prime of x. So let's do the first one here in the corner, x squared plus, or over, whatever that is. Well, numerator we know is x squared. I hope you know that. That makes u prime equal to 2x. And what's our denominator? 1 plus 2x. So v prime, you must know, is going to be 2. Right? So let's apply the quotient rule now that we know what the numerator and denominator are and what their derivatives are. U prime times 1 plus 2x v plus v prime u. Except it's not a plus, it's a minus with the quotient rule. And that whole thing is going to be divided by v squared. So let's combine these. It's going to be 2x plus 4x squared minus 2x squared. So we end up with 2x squared plus 2x divided by, that's going to FOIL out to 4x squared plus 4x plus 1. That's the first derivative. We don't want the first derivative. We want the second derivative. So the numerator, u, I'll write the quotient rule real fast. U prime v minus v prime u over v squared. So u is the numerator, 2x squared plus 2x. U prime, power rule, 4x plus 2. V is 4x squared plus 4x plus 1. And v prime is going to be 8x plus 4. Power rule again. You see why I expanded the numerator or the denominator out so that we could use that power rule very easily, right? You want to do that if you can, and as much as you can. So let's apply the quotient rule again to get the second derivative. 4x plus 2 this is going to be a nightmare, eh? Minus v prime times 2x squared plus 2x. That's all going to be divided by 1 plus 2x squared. That was the original squared. Okay, so let's FOIL them out. Let's do it in order, right? That's going to be 16x cubed plus 16x squared plus 4x. It's this one. Now let's do these. Plus 8x squared plus 8x plus 2. That's just the first part. Minus 16x cubed plus 16x squared plus 8x squared plus 8x. Okay, some of these should be able to cancel. 16x cubed cancels. 16x squared cancels. The 8x squared seems to cancel. The 8x seems to cancel, so I guess we're left with 4x plus 2 over 1 plus 2x to the fourth power. That'll be the first quotient. Ugh. The quotient rule is something you want to avoid whenever possible. Maybe now we all agree. Let's do one more. This one, maybe it's a little easier. I want to point out that this is a conjugate as x plus 1 times x minus 1. I don't know if that's going to come in handy, but you always want a spot where you have an a squared minus b squared. There's a reason it's one of the only 5 rules we have up here today. Okay? So, what's the numerator for this one? We're doing a double derivative. U is x, so u prime is going to be 1. V is x squared minus 1, so v prime is 2x. See, we can use the power rule and the exponential rule to get through the quotient rule and the larger rules that we're going to be learning. So it's all going to build on itself, I promise, I promise. So u prime v minus v prime u all over that v squared. And that would be x squared minus, or sorry, x to the fourth minus 2x squared plus 1, I think. That looks right to me. Okay, so we get x squared minus 1 minus 2x squared. So I'm seeing a negative x squared minus 1 on top, x to the fourth minus 2x squared plus 1 on bottom. This is the first derivative here. So we have our first derivative. Now let's use the quotient rule again. Our u value is negative x squared minus 1. U prime is going to be negative 2x. Our v is x to the fourth minus 2x squared plus 1. V prime, simple polynomial power rule again, 4x cubed minus 4x. And that's it on that one. So let's apply the rule. U prime v minus v prime u. I'm not really thinking. I'm just putting the rules in, right? And of course you can make arithmetic errors, but you can walk yourself through that. Mostly it's about whether or not you can apply the rule. So negative 2, let's come over here, and it's all going to be divided by v squared. I'll do that in a minute. I'm working on the numerator. Negative 2x to the fifth plus 4x cubed minus 2x minus this whole group. That's going to be negative 4x to the fifth minus 4x cubed. That's right. Then we're going to have a plus 4x cubed and a plus 4x. So all of that switches. So let's see, we have a negative 2x to the fifth and a positive 4x to the fifth. So we get 2x to the fifth. And we have a 4x here. These actually canceled. That's kind of weird, but it happens. So it looks like that's 4x cubed. We have no x squared. So here's a minus 2. This one's done. And a minus 4. So that'd be minus 6x over, what was the original denominator? X squared minus 1. To the fourth. Right, this is an expanded version of x squared minus 1 squared. And then we squared again to get to the fourth. So if I want to simplify it all, what can we take out? We can take out a 2x. And we get x to the fourth plus 2x minus 3 is x squared over x squared minus 1 to the fourth. What about this? Can we do this some more? What multiplies to make negative 3 and adds to be positive 2? Plus 3 and minus 1. So we'll do 2x, x squared plus 3, x squared minus 1 over x squared minus 1 to the fourth. I think we can cancel one of these out. And so our double derivative, see, it's a conjugate, right? Or it's a FOIL factor thing, would be 2x, x squared plus 3 over x squared minus 1 to the third power. That's going to be our other quotient. So you can see how quickly these double derivatives and quotient rules can really spiral out of algebraic control, and that's exactly why we come up with these rules. We don't want to do this by hand later. So get these down and make sure you get to the right answer, and then let's go to the next chapter and learn how to do it in a faster way.